Hi, welcome back. In this video, we're going to work on example 2, sketching a graph. What we're going to do is we're going to see what transformations we need to apply to a base graph in order to obtain a transformed one. Okay, we're going to describe those transformations in words, and then we're going to go ahead and just apply them in order to obtain the graph. Okay. After that, we'll talk about domain and range, and then we'll do some other things as well too. All right, so let's get this one started. Part A, what do we need to do to this function in order to obtain this function here? So I think the easiest way to do these is to identify the parameters. So A would be 4, and this one, K, would be 3. Okay, and this plus 1 is not inside a bracket, it's outside, so this is a C value. Once you identify the parameters, you know what transformations need to be made. So A equals 4, therefore vertical stretch by factor 4. K equals 3, so therefore we have a horizontal. This will be a compression by factor 1 over 3, because it's always 1 over K. And C equals 1, therefore shift up 1 unit. Okay, so those are the transformations in words. So how can we go ahead and do this to obtain the graph? Well, we'll do each one step at a time. It's not really the best way to graph, but it still works, so it's still good to see. So there's the y-axis. Here's the x-axis. We're going to have to start by showing sine first. So there's 360. Halfway is about right there. Another halfway there. Okay, so the x-axis is now labeled. I'm going to keep this a little bit small because we're going to be changing the amplitude pretty soon and shifting up, so I want to make sure everything fits. So 2, 3, 4, 5, that will actually work. Okay, so our sine graph, our basic one, we're going to have points there, 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 and there. Those line up with my max and min values. And now I'll color code each one. So we can do this first, the vertical stretch. By the way, if you're doing transformations one step at a time, you have to do them in the right order. So remember, we always do stretches and compressions first. You have to make sure you do the shifts last. So it's like following bed math, right? You want to do your multiplication first before you do any addition or subtraction. So it looks like a vertical stretch of 4. This point right here gets multiplied by 4 and ends up moving up to 4 right up here. Okay, that's a height of 4. Okay, any points on the x-axis don't change during a vertical stretch because when you multiply a y value of 0 by 4, it's still 0. Okay, and then we're going to have another one all the way down to -4. So 2, -3, -4. So that would be down here at -4. So just draw the curve through. Oops. Okay, so this is y equals 4 sine x. Now we'll go ahead and we'll do the horizontal compression next. So we have to compress this by 1/3. So we're basically dividing each x value by 3. Okay, this will be a little bit hard to do. It also means that like three full graphs are going to fit from 0 to 362. All right, so if I'm going to basically multiply all the x values by a third, this one's at 90. 90 times a third is going to become 30. So I'm going to chop all these up into thirds here. That'll kind of help get some of the points. So 90 times a third is going to be 30, so that'll be right up here. So this first one is 30. My next point at 180, 180 divided by 3 is going to be 60. That'll be right here. And then this point at 270, divide that by 3 and I get 90. That'll be down here. So notice it's still following the nice sine pattern with the points. I can actually go ahead and just finish this. I don't have to keep multiplying the x value. So that's what I'm going to do. I'm going to follow our pattern of like max, middle, and then minimum. I can draw that like this. So that's going to be y equals 4 sine 3x. Okay, we got one more transformation left. We'll leave that next. That's our vertical shift up 1. So all the points just bump up 1 unit for the vertical shift. It's pretty easy to do. And that's our final graph. Okay, I normally don't really graph this way. I like to do it how I have graphed in previous videos where I map out the center line first, right? And you can see that here. C would be at 1 in the equation. I always draw that first. And then I go ahead and I plot the amplitude, right? And we can see an amplitude of 4 because we go 4 up and we go 4 down. And then we just work with the period and then the phase shift. Okay, part B. So it wants the domain and range for both functions. So for f of x, the domain is x is an element of R because this is just our basic sine graph. And the range, y is an element of R, and sine just goes from -1 all the way to +1. So our y values are between -1 and 1. Okay, for our transform function, the domain is still x is an element of R. That can't change. But the range, that one will. We're going to have to go from our max to min. So it looks like our minimum is at -3 and our max is at 5. So our max is at 5. Our minimum is at -3. So we can go from -3 all the way to +5. Okay, last question. Modify the equation for g of x to include a phase shift of 30 to the right. Call this function h of x. Apply the phase shift to the graph of g of x and transform it to h of x. Okay, so we're just going to modify our g of x to make it to show a phase shift of 30 degrees to the right, and then we'll call it h of x. So we'll have to do this Maybe we can do this in red. Okay, so 30 degrees to the right. So all the points move over 30 to the right. So we can do it on the graph, but we also want to write out the equation also. So let's do it on the graph first. All those pink points are going to move 30 to the right. Okay, so call that h of x. And the equation for h of x. So it's supposed to be g of x. 30 to the right means we're going to have a phase shift of 30. Okay, this is showing the transformation that we would do to g of x. I still want to write out the actual equation. So it's going to give myself a little bit more space here. So my equation is 4 sine 3 x plus 1. So I left a little space there to show the phase shift. If that has to go 30 to the right, I want to write minus 30 inside. Okay, and that's my equation for h of x. So notice this is pretty much equal to g of x, except I have to include the phase shift, right? So that's what I have in here. Okay, that's it for example 2. Hope you found this helpful. I'll see you in the next video.